Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am Arif and I welcome you all in today's session. Well, to access the notebook for today's session, you can access the course page on my personal website arif.me. You can click the appropriate link under this lecture resource column over here to view the notebook in NB Viewer and run it online in Binder. Well, the other way is to download this notebook from the course GitHub account RFPUCIT, and all notebooks for this course are housed in this public data science repository. Well, this is the Jupyter Notebook dashboard running locally on my machine at port 8888. And here is the notebook for today's session. Lecture number 3.25 of the third module, Python Programming for Data Scientists, for the course titled Tools and Techniques for Data Science. Well, my dear students, today is our fifth and the last session on data visualization. In the previous four sessions, we step by step learnt the usage and design of different graphs on different real-world datasets using the matplotlib library. Well, the graphs that we have covered in the last four sessions are the line, bar, scatter and pie charts, histograms to display the frequency of numerical data, box and violin plots to check the spread of the data using interquartile range, heat map to graphically represent our two-dimensional data using different color maps, and finally we also discussed the concept of subplots in a single figure object. Well, in today's session we are going to design all these charts again, but this time using the Seaborn library. My dear students, Seaborn is a data visualization library built on top of matplotlib. It offers you better functionalities, simple and more elegant code as compared to matplotlib. However, Seaborn inherits a lot of code from matplotlib, so that means you can continue to use a lot of matplotlib code in order to upgrade your Seaborn figures. Well, other than matplotlib, Seaborn also interacts with another Python library called pandas, and Seaborn can directly plot the data from within your pandas data frame, which was not possible with matplotlib. Last but not the least, Seaborn library comes bundled with many different datasets for performing various statistical operations, both descriptive as well as inferential statistics that are involved in different data science and machine learning tasks. Okay, so let us visit the official documentation page of Seaborn, seaborn.pydata.org. My dear students, make time to visit the links under this features column. Let me just spend 1 minute on each of these pages, which I have already opened for you. Well, my dear students, in order to understand how different variables in a dataset are related to each other, you can use the figure level function relplot to draw scatter as well as the line plots. Moreover, here you can find out different arguments that you can pass to the relplot method to have different styles, and finally this relplot method actually can draw the line graphs as well, different styles and colors. And over here, since this relplot is based on facet grid, you can use the visualization, that is you can do the subplots, or you can create multiple axis objects within a single Seaborn figure, as we have done in case of matplotlib as well. Great. Okay, so in order to understand how the data of a variable in a dataset is distributed, we normally use the histograms. Over here, in case of Seaborn, you can use the figure level function displot, using which you can plot univariate as well as bivariate histograms, KD plots, and ecdf plots. And over and above, you can add a rug plot on any of these plots. Well, my dear students, on this page you can check out different arguments that you can pass to displot and have beautiful histograms, different values of bins categorized as per categorical variables in your dataset. You can have kernel density functions as well. And you can have these multiple graphs, as we can have seen in the previous page as well. So these are kernel density estimation functions as well. Great. So we need to do all these things practically. And we can have empirical cumulative distribution functions with the monotonically increasing curve through each data point. And you can use displot to display bivariate distribution, like matplotlib's this heat map. And over here you can see the contours, and these are once again joint plot method of Seaborn, which by default display the bivariate distribution using the scatter plot and the marginal distributions using hist plot. And of course you can change these the default behavior of joint plot method. And finally, of course, in order to plot many distributions, you can use the pair plot method of the Seaborn. Okay, so once again, Seaborn RELPlot, a relational plot method for line and scatter plot, is used to show the relationship between numeric variables of your dataset. My dear students, if you want to visualize relationship involving categorical data, you can use the catplot method of Seaborn, using which you can draw this strip plot, swan plot, box plot, violin plot, bar plot, count plot, and so on. Please do go through this page, where you can see examples of all these categorical plots. Great. So finally, in today's session, I will be covering the first three figure levels, that is the RELPlot, displot, and the catplot. Probably in our mathematics for data science module, we will talk about visualizing linear regression models using this LM plot and reg plot method of Seaborn. Okay, I think enough of theory. Let us practically do all of this and fall back to our notebook. Great. So this is the learning agenda of today's session. We are done with the overview of Seaborn library. Next, we are going to download and install Seaborn. Then we will have a quick survey of some of the important datasets that come bundled with Seaborn. And finally, we will see the three figure level methods of Seaborn library. The RELPlot method for drawing line plot and scatter plot, the displot method for drawing histograms, KDE, and ecdf plots, and finally this catplot method for drawing box, violin, bar, and count plots. So we still have a lot to do today, so let's start playing. Okay, so let me first install this Seaborn. This is a piece of cake for you all. Right now the version that I'm using is 0.11.2. Okay, my dear friends, let us now see the different datasets that come bundled with Seaborn library. And to get a list of the dataset names, you can use the get dataset names method of Seaborn. and this is a list of all the datasets that come bundled with this library, more or less 19 different datasets. Well, let me quickly give a brief description of some of these datasets, and let me start with the dataset car crashes. My dear students, you can use this load underscore dataset method of Seaborn and pass the name of the dataset into to this function, and this will load this dataset inside a pandas data frame. So let me run the code, and over here you can see that this car crashes dataset has been loaded inside this data frame, and we are seeing the first 5 records of this data frame. Okay, it has I think roughly 51 rows. Let me show you the shape of this car crashes. Oops. df underscore cc dot shape. So this is not a method. So we have 51 rows and 8 columns in this dataset, and this dataset contains a record of accidents in different states of the United States of America, and the cost incurred to the insurance companies. This total column specifies the number of drivers involved in fatal collisions, probably in a billion miles. This speeding column specifies the percentage of drivers involved in fatal collisions who were speeding. The alcohol column specifies the percentage of drivers involved in fatal collisions who were alcohol impaired. This not underscore distracted column, this specifies the percentage of drivers involved in fatal collisions who were not distracted. The no previous column specifies the percentage of drivers having no previous accident history. And this insurance premium and insurance losses column specifies the car insurance premium and losses incurred to the insurance companies per driver. And finally, this last column is the abbreviation of the US state, and I think this AL is for Alabama, AK for Alaska, this AZ for Arizona, this AR for Arkansas, I think, and this CA for California. Great. So this is the car crashes dataset. Let me move ahead and discuss another dataset, that is flights. Also a built-in dataset. We can load this dataset as usual with the load underscore dataset method. Let me show you this data frame. So this contains monthly data for 12 years starting from 1949 to 1960. So having 144 rows and 3 columns. Each record contains the count of passengers in thousands who visited the airport. So this first row says that in the month of January 1949, a total of 112,000 passengers visited the airport. So this is the flights dataset. Let me move ahead and talk about another dataset, that is the tips dataset. Okay, so the rows of this dataset contains 7 different values, 7 different columns associated with a paid account in a restaurant. This total bill column contains amount paid in dollars. This tip column is naturally the tip paid. The sex column is the gender of the person paying the bill. The smoker column probably tells whether the client whether the client smoked on the table or not, yes or no. The day specifies the day, the time specified the time, dinner or lunch. This is a categorical variable, of course, and the size specifies the number of people sitting at the table. So this is the tips dataset that we'll be using today, inshallah. And this is another very important dataset, IRIS dataset, that was introduced by a British statistician Fisher in his paper in 1936. And this Fisher is the same person who introduced ANOVA, analysis of variation tests. Anyway, before loading this IRIS dataset into a data frame, let me quickly describe this flower to you. Well, as shown in this figure, there are three species of iris flower: Iris setosa, Iris versicolor, and Iris virginica. Further note the two types of leaves that almost every flower has, a sepal and a petal. Well, this sepal is the outer part of a flower that provides protection to the flower during its bud stage, while this petal are the inner leaves that surrounds the reproductive unit of a flower. My dear students, the iris data set records the sepal and the petal length as well as width of 50 samples of setosa, 50 samples of versicolor, and 50 samples of virginica. Okay, so let me show you the data set. So this is the data set. So you have 150 rows. The first 50 columns contains the sepal length and width, petal length and width of setosa. Next 50 rows contains the same observation for versicolor, and these last 50 rows has the same information regarding virginica. So to summarize, this iris dataset consists of five variables, four numeric ones describing the characteristics of petals and sepals, and this species is a categorical variable containing the three species of iris flower: setosa, versicolor, and virginica. I think that is enough. Let me show you the values count as well. You can see setosa, versicolor, and virginica 50, 50, 50. So great. Let's move ahead and talk about one more very commonly used dataset, and that is Titanic. That is used for learning machine learning basics. It contains information of all the passengers aboard the RMS Titanic, the Royal Mail ship that sank after colliding with an iceberg, killing around 1,502 out of 2,224 passengers and crew members. Let me load this dataset in a data frame using this Seaborn load dataset method. Okay, so I've shown you the first 60 records of this. Well, my dear students, this contains information of 891 passengers out of 2,224 passengers on board. And this data frame has 15 columns other than this passenger ID. The survived column contains 1 or 0. 1 means the person survived, 0 means died. This P class is the passenger class, first, second, or third. This sex and age, sex is a binary variable, and this may have two values, male and female, categoric variable, and this age is a numeric continuous variable. This SIB SP basically is the number of siblings and spouses on board. This column PARCH, these are the number of parents and children aboard, and they represent the count. This fare column is the passenger fare in British pounds, a continuous variable again. This embarked column is a categorical column having three values. S stands for Southampton, C stands for Queenstown, and this Q stands for Queenstown, and you may find a C over here which stands for Cherbourg. Anyway, so we have a class. Once again, we have class first, second, and third. These are strings. The who column contains three values: man, woman, and maybe child. This adult underscore male column contains true if a passenger is adult male. This deck column contains name of the deck, A, B, C, D, E, up till G, I think, and have many NaN values as well. This embark underscore town, this contains the full name of the town, and this alive column maps to this survived column over here. If we have a 0 over here, we have no, and if we have a 1 over here, we have yes. Fine. And finally, this alone column, the 15th column, contains a value of true if the passenger is alone, and false if any of the corresponding values to this sibling, spouse, or parent child is 1. Great. So enough of discussion about the built-in dataset of Seaborn. Let us move ahead, and let me quickly give you a kickstart in next 15 to 20 minutes, which will help you learn Seaborn and draw beautiful graphs with it. My dear students, since the release of Seaborn version 0.11, there exists a proper grouping of plotting functions. And I think you just need to know these three top level functions: this relplot, this displot, and this catplot. You can use a displot method for both univariate and bivariate distributions, using which you can create histogram plots, kernel density estimation plots, and empirical cumulative distribution plots, as well as the rug plots. And similarly, this relplot method is for relational analysis. You can pass it the kind argument to have a line or a scatter plot. And finally, this catplot method is for the analysis of categorical features. And to the kind argument of this method, you can pass the kind of the graph you want to draw. So let's jump into code now. Let me just import the required libraries, and let me ignore the warnings. Well, the alias of Seaborn is SNS as per the Stack Overflow page. I have checked it out yesterday. This is the abbreviation of the name of the fictional TV series character, Samuel Norman Seaborn. Well, this is just a side note. My dear students, you can use the set underscore style method of Seaborn to set some of the style parameters of the plots in general. Well, you can pass one out of the 4 parameters to it: white, white grid, dark, and dark grid. And similarly, you can use the set underscore context method of Seaborn to set the parameters that control the scaling of plot elements. The context argument can be paper, a talk, or a poster. Okay, let us start by drawing a line plot using the relplot method. Of course, relplot stands for relational plot. And let me draw a line plot using this Iris data set that we have already loaded in the pandas data frame, df underscore iris. Let me show you the head of it again. The sepal length, sepal width, petal length, and petal width of 3 different iris species: Setosa, versicolor, and virginica. Let us see the brief statistical description of the 4 numeric columns in this data frame. Okay, so let me draw a line plot to display the relationship between the sepal length and sepal width. Note the x argument to the rel plot is passed sepal width, and the y argument to the relplot method is passed sepal length. and the data argument of rel plot contains the name of the data frame, that is df underscore iris. Well, my dear students, the default value of the kind argument to the rel plot method is scatter. So I have explicitly mentioned the kind of plot to be line over here. Let me execute this cell. Great. So this is a line chart with the sepal length along the y-axis and sepal width along the x-axis. My dear students, you can see the hue argument as well to rel plot. You can pass this argument to rel plot. Over here I have passed it, the hue argument, and to this hue argument I have passed the name of the categorical column species. So if I show you the graph now, you can see that we have now three different lines over here. One line representing the setosa, the other versicolor, and the third one is for Virginia. And from this graph we can observe that iris setosa, shown in blue, has sepal width not less than 2.3. You can see that the sepal width is not less than 2.3 and sepal length not greater than around 6 centimeter. Similarly, the iris versicolor shown in orange line over here has not less than 5 centimeter sepal length. The sepal length is not less than 5 centimeter. And sepal width not greater than 3.4 and sepal width not greater than 3.4. And similarly, iris virginica, shown in green over here, has a sepal length not less than 6 centimeter. You see, this sepal length is not less than 6 centimeter, and the sepal width not greater than 3.8. And the sepal width is not greater than 3.8. One more point that we can see in this graph is the sepal length and width of iris setosa, which is clearly distinct from the other species, other two categories of the iris flower. Okay, so let us have different styles for these three lines. Let's see that. I have just added this style argument to the rel plot now, and I've passed it the same categorical variable species. Let me run this code. Great. So over here now you can see that the solid line is there for setosa, a dashed line for versicolor, and a dotted line for virginica. Great. Let me move ahead and see the scatter plot, and let me show you the data frame containing the tips dataset. Okay, so these are the first 5 records of this data frame, and of course this dataset contains 7 different values associated with a paid account in a restaurant. And let me draw a scatter plot to display the relationship between these two numeric columns, the total bill and this tip. Okay, so let me come up over here, use the rel plot, pass it the kind as the scatter. Along the x-axis I am keeping the total bill, and along the y-axis I am keeping the tip. And of course the data is coming from this data frame df underscore tips. Let us execute the code in this cell. Great. We can see that we have total bill along x-axis and the tip along the y-axis, and these are the different data points. If you see closely that more is the total bill amount, more is the tip, okay, and less is the total bill, lesser is the tip. Moreover, the bulk of the tip amounts resides between $2 and $4. For just learning sake, let me check out the amount of tips given by smokers and non-smokers. Let me check out. I can do that by passing the hue argument to the same piece of code. I have written it to save time. Let me run this. The blue points over here now are the smokers, and the orange points are for non-smokers. So you can see that maximum tip has been given by a smoker, and that is around $10. This blue, $10, great. Let me change this hue argument to, let's say, day, the day column of the data frame, and let me run it. Now you can see we have these data points for the 4 days, different colors: Thursday, Friday, Saturday, and Sunday. So this is great. By just quickly viewing this scatter plot now, one can make out that the maximum tips has been given on Saturdays, I think, the green one. These are the maximum tips that have been given on the Saturdays. Let me change this hue to another categorical column, that is sex. And let's check that now. Great. And now you can observe that the male customers shown in blue are the ones who gave the larger tip. Okay, so one more thing that we can do is we can change the style of the markers or these dots by passing the style argument to the categorical column. Let me pass the style argument, and let me say style is equal to, and let me pass the column. And now you can see that we are having blue circles for the males and orange crosses for the female customers. My dear students, this relplot method is built on top of facet grid. So we can have subplots. If you see over here, instead of passing the smoker categorical column variable to the hue argument, I am passing another argument to the relplot, and that is col. Rest of the arguments are same. So we have two values in this categorical variable smoker, yes and no. So we will have two separate graphs. Let me run this code and show it to you. So we have two separate graphs. On the left over here we have a scatter plot for the smokers. Smoker is equal to yes. And on the right over here we have a plot for the non-smokers. Smoker is equal to no. So it shows that we have less number of smokers who visited the restaurant. Okay. My dear students, if you want to show these two subplots in rows, right now they are shown in a single row but in two columns. If you want to show them in rows, you can just change this call to row and run it again, and now you can see that we have two rows for this. Great. Let me change this row argument back to call so that we can have a view of both these plots in a single screen. And let me pass day argument to this and check out now what happens. So since this categorical variable day has 4 different values, Thursday, Friday, Saturday, and Sunday, So you can see 4 different plots over here. And this shows that we have a less number of customers visiting on Friday in the restaurant. And my dear friends, finally, if you want to display these 4 plots in a grid instead of inside a row, you can use the call underscore wrap argument. Let me pass that argument as well. Call underscore wrap, and let me pass it an argument 2. So what this will do is this will wrap after 2 columns. That is the first column, second column, it will wrap third, fourth, then it will wrap and so on. So since we just have the 4 different graphs or the subplots, so we have 2 rows and 2 columns. My dear friends, the way we have created this facet grid for scatter plot, you can easily do the same for the line plots as well. Okay, I think that is enough for the rel plot method. Let's move on and talk about the cat plot method now. Well, the cat plot method is used to display categorical estimate plots, categorical distribution plots, and categorical scatter plots. My dear students, I will give you a kickstart on this quickly, and you should dig out the rest on your own. And let me show you the Titanic dataset that we have already loaded in pandas data frame, that is df underscore Titanic. The survived, sex, embarked are some of the categorical columns over here. This passenger class is an ordinal column. The age and this fare are numerical and continuous. This sibling, spouse, and parent child are numerical but discrete. So this is a brief summary that I have repeated again. Let us check out the relationship between the categorical variables survived and sex. And survived, where is survived? Over here. And for that, let us use the bar plot. Okay, so this is the cat plot. I am passing sex to the x argument and survived to the y argument of cat plot. The kind argument is being set to bar, and of course that data argument is set to df underscore Titanic. Let me run the code of this cell. Great. So this is a Seaborn bar chart. You can note that around 70% of the female passengers, they are the one who survived. 70%, more than 70%, I think. While less than 20% of the male passengers survived. So this is what we got the information from the bar graph. And let me show you the count plot as well using the cat plot. I am just passing the x argument this time, the sex to the x argument, the count to the kind, and of course df Titanic is the data. Let me run the code of this cell. So this is the count overhead. Note that over here we have this survived value 0 to 1, and now over here we have the count. Great. So out of 891 passengers, we have over 550 male passengers. So this is the count of male passengers, and around 300 female passengers. Okay, so let us just pass the hue argument to the same cat plot and pass it the categorical variable survived and run this code and see what it gives you. So now we see 2 bars for the male passengers and 2 bars for the female passengers. Once again showing the count of the survived and not survived passengers. Now we can easily see that over 200 of the female passengers survived out of a total of around 300. So great. Okay, let me move ahead and see the box plot now. My dear students, we have seen the box plot in detail in our matplotlib sessions and also talked about the 5-number summary. It tells us the min, the max the first, second and third quartiles. We can of course draw a box plot by just passing this box argument to the kind argument of cat plot. Over here I want to draw a box plot for the numerical column age and the categorical column sex. Let's just run this code. So this is a box plot for the male passengers, and this is for the female passengers. These two lines, one in the bottom and one at the top, shows the min and the maximum ages for the male passengers as well as for the female passengers. While these three lines are the three quartiles, Q1, Q2 and Q3. Remember this middle line of Q2, the second quartile, is the median. Over here in the male box plot, these three markers at the age of 70, probably 73 and 80, I think these are taken as outliers by Seaborn. Okay, so well, once again you can use the hue argument over here as well. I am passing the column survived to it. Let me run it again. And now you can see two box plots for male passengers, one in orange color and the other in blue color. The orange one shows the box plot for male survived passenger over here, and this one for the male passengers who didn't survive. And similarly we have two box plots for the females as well, survived and not survived. So I think we have covered this in detail in our matplotlib session, so this is quite clear to you. Let me move ahead and talk about violin plot now. Well, we can simply set the kind to violin once again to the cat plot. Let me run this code. So these are the two violin plots showing the male and the female ages over here. And note that it also shows the probability density of the data at different values. And of course we can use the hue argument again. I have passed the hue argument, the column survived. Let me run it. And now we have two violin plots for the male and two violin plots for the female for both survived and not survived. Great. Okay, so next plot is the strip plot. You can use the cat plot method to draw a strip plot. My dear friends, the default value of this kind argument in the cat plot is the strip plot, but I am explicitly passing it over here. Let me show you a strip plot for a single variable first, that is the age. Let me run it. You can see the bulk of the passengers. They fall between the ages probably 20 and 40. Let me move ahead and use pass two arguments to this cat plot now, the sex and the age. Let me run this code, and now you can see we have the strip plots for the male separately and for the female. So these are the ages. So now we can see separate data points for male passengers as well as the female passengers, while over here we just have the male and the female passengers, and we have age on the x-axis over here. You can set the age along the y-axis over here if you want to. Have a view of this like this. I hope this makes sense. And over here I am passing the hue argument and I am passing survived once again, and you can see we have now two colors for the male, two colors for the female, blue for not survived and this orange for survived. Okay, let's move ahead and talk about the swarm plot. Well, you can pass the swarm argument to the kind in the cat plot method. Over here I have added hue in the very beginning. Let me straight away execute this code. Looks really beautiful. So this is swarm plot that resembles a swarm of bees. My dear students, it is a categorical scatter plot similar to the strip plot, except that the location of points are automatically adjusted to avoid overlap. So that is why it looks good to you. Okay, so far so good. Let me talk about the subplots. My dear students, like the rel plot, this cat plot method is also built on top of the facet grid. So we can have subplots. So this is a box plot of the numeric column age for male and female passengers. Let me run it. So these are the box plots we have seen before as well. If you want to show these in two columns, just use the call argument instead of hue. We can use the call argument instead of hue, or we can keep it like this and use the call argument. And let me run it. So this is great. So now we have two subplots, one showing the box plot for male and female passengers who didn't survive, and one for the male and the female passengers who survived. And you can observe the outliers over here. Well, my dear friends, I think that is enough for the cat plot method. Let us move to the third and the last method, and that is displot. Okay, so over here we again have the column of survived. Okay, so we have displot now. My dear students, in order to understand how the data of a variable in a dataset is distributed, you can use the displot method, using which you can draw a histogram, a kernel density estimation plot, or a empirical cumulative distribution plot. And let us start with a histogram that we have of course seen in detail in our previous session of matplotlib. And let us create some histograms using the tips dataset and Seaborn library methods. So this is the tips dataset. Let us create a histogram for this numerical total bill column to check out its distribution. Let me show you the min, max, and the mode values for this total bill column. So the min is around 3, the max is 50.8, and the mode is 13.42. Great. So let us use the displot method now to display a histogram. So I have used the displot method. I have passed the total bill as the x argument. The kind is hist, and of course the data is df underscore tips. So this is a histogram. Great. So the data is, I think, divided into 15 bins along the x-axis, and we have the total bill along the y-axis, which is the count of frequencies over here. And we can always change this bins argument to a different value. Let me pass 32 bins and see the behavior. And now you see we have 30 bins. So great. I think this is making sense to you all. Let me move on to the next type or next category, that is the KDE, kernel density estimation. Well, KDE plot allows us to estimate the probability density function of a dataset. Note that over here once again I have passed the kind to KDE, the kind argument to displot. Let me straight away run it, and along the x-axis you can see we have the total bill, and along the y-axis we have the density. Great. My dear students, you can always pass the fill argument to this displot. You can pass a fill argument to true, so this will just fill up this histogram or this plot, And of course, you can overlap a histogram and a KDE plot together. You can just pass the kind as hist and the KDE as true. So once you run this, you have both the histogram as well as the KDE. And of course, you can use the hue argument. I have passed the hue argument over here, and I have passed the categoric column day to it. And of course, this will show me the KDE for the 4 different days: Thursday, Friday, Saturday, and Sunday. Great. My dear students, I hope this is making sense to you all, since we have covered a lot many things in our previous 4 sessions of Matplotlib. So my speed might be a little bit fast for those in particular who have not seen those videos. Anyway, my dear students, let me run this as well. This is also the same, probably. Yes. Okay, so the next type of graph that I'm going to discuss is ecdf. That is the empirical cumulative distribution function plot. Let me execute the code of this cell. Okay, so we have this tip along the x-axis, and for every tip value, this line moves up, and from 0 it finally reaches to a proportion of 1. Well, this line moves from the smallest tip value, which is $1, and moves up to the maximum tip value, which is probably $10. So an ecdf plot plots from minimum to the maximum. Over here, you are seeing a large vertical line. That means that it is the most occurring value in the dataset. For example, over here you can see this value $2. This $2 tip is the most occurring value over here. Because for this the proportion moves from 0.18 to probably 0.3, I think, showing the most occurring tip value. So this is $2. Let us confirm this by using the value counts function. Let me use the value counts function, df underscore tips. On the tip column, let me use the value underscore counts function. Well, my dear students, this function displays the count of unique values under this particular tip column. So you can see that we have a frequency of 33 for the tip 2. One more observation that we can make from this plot is that 80% of the tip amounts are less than $4. You can see 80% of the tip amounts are less than $4. And 98% of the tip amounts are less than $6. So over here we have 98%, I think, and you can see that 98% of the tips are less than $6. Fine. Let me add a hue to this now. Let me add a hue, HUE, and let me pass the time to this, lunch and dinner. So we have now 2 lines, one for lunch time and the other showing the tip proportion for the dinner time. You can note this blue vertical line over here, this long blue vertical line. At the lunch time shows that we have a lot of $2 tips. The orange bar shows that we have a lot of $3 tips over here. Yes, this vertical line. So great. My dear students, I hope that ecdf plots are a bit clear to you now. Let me move ahead and see what else is left in today's session. Okay, bivariate analysis. My dear students, up to now we have used a single variable in the displot. And over here I am using now 2 variables, that is the total bill along the x-axis and the tip amount along the y-axis. And the kind is the histogram, and let me run this code. Great. So quite similar to matplotlib heat map, we can use this C bar is equal to true to add this color bar over here. So let me move ahead and let me just change the kind to KDE. This is similar to this. I've just changed the kind to KDE and the graph is changed now. So instead of colors, you see contours now, and the contour lines are close or thick where we have more tips. Great. Well, my dear students, the way we have used the facet grid with the relplot and the catplot methods, we can use it for the displot method as well. Let me straight away run this line of code. Okay, so this is a histogram based on the hue day. So actually there are 4 histograms for the 4 days shown in different colors, but we cannot see the 4 distributions clearly as the colors and the bars are overlapping over here. So let's once again use the call argument as usual to have multiple subplots. Call is equal to, let me pass the categorical column day to this, and great. You see, this time we have not removed the hue column and we have this colorful plots, 4 histograms for Thursday, Friday, Saturday and Sunday, and we have this legend as well over here. Well, my dear students, I'm really tired. This was a long session, but I'm sure that today I have given you a reasonable knowledge to start your journey of visualizing data and doing exploratory data analysis using the Seaborn library. Okay, so that is all for today's session. We will inshallah continue our journey to learn Python programming for data scientists in our next session. And I hope today's session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. I wish you all the best, happy learning, and Allah Hafiz.